When you are born, your skeleton is not finished. Some of your bones are still growing. Some have not fully hardened yet. And some are not even separate bones yet. Your skeleton changes quietly while you grow. It changes shape, it changes size, and it changes strength. At birth, a baby has roughly 270 bones. An adult usually has 206. That sounds impossible. How can hundreds of bones simply disappear? They do not disappear. Many bones gradually fuse together. Your skeleton is more like a construction project than a finished building. And the strange part is this: your bones are alive. They contain blood vessels, they contain nerves, and they constantly rebuild themselves, even while you are sleeping. Your skull shows this process especially clearly. A baby's skull is not one solid shell. It contains separate bone plates. These plates can move slightly. They also leave spaces between them. You may know these spaces as soft spots. Doctors call them fontanelles. They help the baby's head change shape during birth. They also allow the brain to grow rapidly afterward. And the brain grows remarkably fast. By about age 5, the human brain has reached most of its adult size. But the skull keeps changing. The separate plates gradually become more firmly connected. Eventually, many of their borders become almost impossible to see. Your spine changes too. A newborn spine has a different shape from an adult. As babies develop, they learn to hold up their heads. Then they sit, then they stand, then they walk. Each new movement changes how the spine is loaded. This helps create the characteristic curves of the adult spine. Those curves are extremely important. They help the body balance above the hips. They also help absorb forces during movement. But the biggest transformation happens inside your bones. Long bones grow from special regions called growth plates. Growth plates are areas of cartilage near the ends of growing bones. They act like temporary construction zones. New tissue forms there. Then that tissue gradually becomes bone. This is how your arms and legs become longer. The process is called endochondral ossification. It sounds complicated, but the idea is simple. Cartilage provides a growing framework. Bone gradually replaces it. And this continues throughout childhood and adolescence. Then something surprising happens. The growth plates eventually close. Once they close, the bones cannot keep lengthening in the same way. This is one reason people stop getting taller. The timing differs from person to person. Genes matter, hormones matter, nutrition matters too. And the timing is not identical for every bone. Your skeleton is also becoming denser while you grow. Bone-building cells called osteoblasts create new bone. Other cells called osteoclasts remove older bone tissue. This sounds destructive, but it is actually essential. Your skeleton needs both processes. One builds, the other removes. Together, they remodel your bones. Think of it as constant maintenance. Your bones are adapting to the forces placed on them. Walking sends repeated forces through your legs. Running sends stronger forces. Climbing changes the forces again. Your skeleton responds to these demands. This is one reason bones are living tissue.
They are not simply hard structures holding you upright. They are constantly communicating with the rest of your body. Calcium is especially important. Your bones store a huge amount of the body's calcium. Your body can release some of that calcium when necessary. Several hormones help control this balance. One important hormone is parathyroid hormone. Another is calcitonin. Vitamin D also helps your body absorb calcium from food. Together, these systems help maintain healthy bone tissue. But growing bones have another challenge. They must become larger without becoming uselessly heavy. Your body solves this with remarkable architecture. Inside many bones is a lightweight structure called trabecular bone. It resembles a tiny three-dimensional framework. It provides strength without filling the entire bone with solid material. The outer layer is called compact bone. It provides much of the bone's hardness and resistance. So even a bone is engineered in layers: strong outside, lightweight inside, and constantly changing. By adolescence, the skeleton has already transformed dramatically. The limbs are longer, the joints are larger, the bones are stronger, the skull has matured, and the growth plates are gradually closing. But the skeleton still is not frozen. Bone remodeling continues throughout adulthood. Old bone is removed, new bone is created. The balance changes with age. This is why bone strength can change later in life. Your skeleton carries evidence of your entire history. It responds to movement, it responds to growth, it responds to hormones, it responds to injury, and it responds to the demands you place on it. So why would evolution build a skeleton that constantly changes? Because a growing human needs a growing framework. A baby skeleton must support a tiny body. A teenager skeleton must support a rapidly changing body. An adult skeleton must support a fully developed body. One structure cannot perfectly fit all three stages.
So your skeleton rebuilds itself, piece by piece, year by year. And there is something almost strange about that. You may think of yourself as having one skeleton, but technically, you have spent your entire life becoming a different version of it. The bones inside you today are not simply the bones you were born with. Your skeleton has been remodeled again and again. It grew with you. It adapted to you. And it quietly recorded the story of your growth. The strange truth is that growing up does not just change how you look. It changes the structure holding you together. Your skeleton was never a finished frame. It was always part of the journey.